Hello everyone and welcome. We are here today to help solve t-distributions and their confidence intervals. So first things first, a t-distribution is used to estimate population parameters when you have a small sample size or you don't know what the population variance is. It is developed by William Seeley Gossett in 1908 and it uses a t-table like this. It is sorted by the degree of freedom and the degree of error or confidence interval percentage. So, for example, we have the test scores of 8 randomly selected students, which are 80, 82, 85, 87, 89, 91, and 93. And we have to compute the 98% confidence interval of the true population mean. So first, here are the given. The sample size n is 8. Confidence interval rate of 98%. Degree of error or A of 2%. One tail of 1%, which we get by having the degree of error. The degree of freedom or DF, which has a formula of sample size minus 1, where we get 7. And now we need to find the critical value, sample mean, and the standard deviation.
Now to find the critical value, we need to use the t-table. We use our degree of error designated as 2 tails or the 1 tail. Either is fine. We just have to convert the percentage to decimal to find it. Then we also use the degree of freedom, so we find that our critical value is 2.998. Next, we need the sample mean. We can find it by adding all our samples, divided by the sample size. So here we add all the grades together and divide it by 8, so we get 87.75. Now, lastly, we need to find the standard deviation. It's pretty simple but it may take a while. So the formula for the standard deviation is the square root of sigma sample subtracted by the sample mean squared over the sample size minus 1. The sigma sign means the summation of that equation, meaning we have to use all our samples, subtract each one of them by our sample mean, then square the sum. Then we'll add it all together getting 193.48. 8 minus 1 is of course 7. 193.48 divided by 7 is 27.64. Then the square root of 27.64 is 5.25. Now we have the standard deviation.
Now that we have everything that we need for the given, we can now compute for the confidence interval and the margin of error. Now the formula for the margin of error is the critical value multiplied by the standard deviation divided by the square root of the sample size. So put our given, then get the square root of n, which in this case is 2.83 divided with 5.25, getting 1.86. And then multiply to the critical value. So our margin of error is 5.56. Now for the confidence interval, we just need to subtract the margin of error and the mean, which gets us to 82.19. Then we need to add for the next value, which gets us 93.31. So our confidence interval is between 82.19 and 93.31. Well, that's it for today, everyone. Thank you for watching and goodbye.